So let's begin with a very, very important concept in the algorithmic, etc. So it's the Prim's algorithm. So why it's so important? So let's begin. All right. Um, but why Prim, right? So there was a man called, you can see the name of him, this mathematician, Yarnik, that he created this algorithm, and it's very important to know it, right? For competitions like Google Code Gym or even Google Code Star, Kickstart. So we'll motivate with the following application. So that uses Prim's algorithm for doing it. So why it's so important? For example, suppose you want to make a path for integrated circuits, which is an area of electronics, or also finding the minimum spinning tree. It's a very important thing that we also know, right? Also for TV networks, for AI things, discovering cheaper paths connecting cities. All of these things are very interesting. And in this video, we will cover this topic here, this fourth topic, that is how to calculate the cheaper paths connecting cities. So it seems there are a lot of things to do with it, and it's true. It's really, there are a lot of things. So let's begin. And we observe that we try to avoid cycles like in graph theory. So, what's a spinning tree? Suppose we have the following graph consisting of four vertices, indexing 0 to 3, considering four cities numbered and their relative distances. So, what's the number minimum of concrete to build roads such that all cities are connected? So, we have to build roads here. So, how much we have to spend for building roads in these, supposing these distances? So let's continue. First, we are going to consider, so it's very important, this problem. I don't have an even to say how important this is for the world in which we live in. So it's very good to have in hand these algorithm. This is an array that consists of the values of distances between the cities. So for example, these distances that are put here. For example, the weight of the zero, so we will have to better this notation. So let's this out. So there, from vertex 0 to 1, there is the distance of 10. From vertex 1 to 2, there is this distance of 10, and so on. So what's the minimum number of concrete that we need to go with it? So let's see how can we do it. We have to print the final result in a graph. So first of all, now we will consider another thing that's important. The prim set, this is the vertices that are included in the prim tree. So this is going to be a bool, right? For each vertex will be included. So we have four. So we need an array of the type bool, and we'll have four spaces to say if each vertex part or not of the tree. And also we'll use int parent to show the construct tree. This is the node parent. For example, the node parent of 1, if we are here, it's going to be 0, right? It's very important. For example, if we are here in 2, 3 and 1 have parent 2. If we are here in 3, if we set 3 as our node parent, 0, 1, 2 will have node parent 3, and so on. We will separate our program in four functions. The main function, another to print the graph, one for prim, and actually it's not quite this way, but we'll see better. And finally, the one that calculates the minimum weight. But we'll see better in the algorithm. So let's go to the code. I have taken this code from Geeks for Geeks because I didn't like so much the explanation, and I'm gonna re-explain here if this word exists for in English. So here we start with our four vertices that we're defining. And as I said, we'll need four functions. This mean, weight, this void print for printing the graph, of course, our algorithm, which is prim, MST, which should be prim set, right? So I think we have to change it, right, for another name that becomes better, like prim set. This is wrong. Let's see if it's correct. All right, we have to change also here, and I think it compiles well. Let's see. All right, great. So let's go to the form that we make the graph. The graph is basically a set of vertices that are joined by edges. So as we have seen, and this graph has v by v vertices in our case. So this is the first vertex, this is the second, this is the third, and this is the fourth. But as we know, in C++, we begin by 0, 1, 2, and third vertex. So this is the 0th, the first, the second, and the third. So this 0, actually, this is the value that we give to the paths that we're considering. So let's go back to, to paint. For example, this one here. For this one here in the position 0, right, we'll have to consider the weight in relation to 0 is 0, of course, it's obvious. The weight in relation to 1 is 10, so we put 10 here. And see that this is 0 position, first position. The 0 in relation to 2 is 0. The 0 in relation to 3 is 10, and we close the first one here. So this is quite right. So this is the 0th position for our vertex. So let's go back to the code. So it's very simple. If there is some noise, don't worry. So this is our 0th. For the first, we have the following. We have the 1, right? This one here. We will have in relation to itself, it's going to be 0. In relation to the, actually, in relation to the 0, it's going to be 10. So it's 10 here. In relation to 1, it's going to be 0. In relation to 2, it's going to be 10, right? Of course. And in relation to 3, it's going to be 14. So this is the way that things work. So, and so on. And so we print the graph. We print the graph. But actually, but actually, how all of these things are working here. So it's quite simple, and we'll try to do it. First of all, we will have this prim set that's going to be calculating the prim algorithm. We have this array constructed, right? So this is the parent node for each time that we will go into our algorithm, and we are going to see how it works really. So we for everything will set the first weight to 0. That's the first thing we're going to do. So here the weight is 0, the first weight. So we're going to have an array of weights from 0 to 3, and for the first one it's 0. And the parent can put a negative number here, any negative number, just to not be 0, or any number greater or equal 0. So we have a prim set that, for example, if vertex is contained in the prim algorithm, we will put true. But if not, for example, if 0 is included, we're just going to put the following: equals to 0. 0 actually equals to true. Equals to true, it means that this first vertex included in our algorithm. So we have to represent it anyway. We have to initialize all values as infinite. So the first weight, it's going to be 2 to the 31 minus 1. This is the maximum amount of bits that the language can store. And we have to print set equals false for all of them, of course. So it's very simple, this algorithm actually. And we have, how can we do this? How can we start? So the first one is 0. So let's go back these things that we have done here. The first one is 0. Oh, sorry. So the first one here is 0. So there is a weight of 0, and this we're going to call u, right? So for weight 0, from 0 to 1, and this we're going to call v, and also this one here. And we are going to see, uh, so I'm explaining some parts of the code, and I'm going to join all the parts soon. So we have to pick each time the minimum weight of our prim set. So, for example, if there is a new here and there are two v's, we have to pick one of these two. But as one is immediately after 0, we will pick one here. So in this part of the code, graph of uv, it's just going to be 0 as it's saying for vertex adjacent, because if it's the same in relation to this one here, it's going to be 0, of course, as we have seen. And the prim set of v equals false. It's not included, so we have to include. And also the graph of uv, in this case here, if it's smaller than the key that we have changed key in the original code, we are putting weight here to be more intuitively correct. So we put weight. As we have put all weights to infinity, actually to a very high value of the computer memory, we expect that this value is going to be less. So actually 10 is less than 2 to the 31 minus 1. So we are going to include this parent of v, which is u, in this case here, u, it's 0, and v, it's 1 in this case. So the weight of 1, it's going to be the graph of 0, 1, which is 10, as we have seen, right? In this case, it's the graph of 0, 1, which is this one here. So we are going to include it in our prim set. So this is basically the code. And how can we get this mean weight here? We have two parameters. We have an array of weights, and the prim set, which is another array of the prim set, of course, of the set of vertices not yet included in the MST set, or the prim set, which is the minimum spanning tree. So we have to go back truly to this function. How can we do it for this function? It's quite simple. We have an array here and another, and we put the mean equals to int max, which is a big number, and we create another variable called mean index. That's very simple, and we really have to know this for Kickstart and other competitions, because it's very, very important to know this kind of problem, to find the minimum, local minimum, to try to see a minimum global. It's very important, this kind of problem. It's called a kind of greedy algorithm. So we have to go along the vertices, and so if the prim set, the numbers, the vertices that are included are not included, and the weight is smaller than min, we just put min equals to weight of the v. For example, if our this one here is not included, we have to see that we have to include this, as we have seen, but one is not included yet, so we have to change this u, and we have to take it out and change this also to u, and also put this new v and this new v here. And we have to take min receives the weight of v, right? Because of this new v that we are having here. So it's quite simple, and it returns the mean index of the function. So the program is really simple, and I also this function we have to know clearly what it means to print the prim set. We have just to print the parent, and of course, as 0 has no parent, we begin with 1, and we also have to print the graph, which is for example, if it's 1, it's 1 and parent of 1. But we know how much is parent of 1, it's 0, so we are going to print 10 in this case here. And so it's quite simple, and you can do it alone. I think combining many ideas, to try to understand it better. First, I recommend I will not do it here because there is another video in the Geeks for Geeks. I recommend it to see of the guy that sent the code, because it's not very important to put here because the other guy has just put in Geeks for Geeks, and I suppose you don't really just see one video, just watch more videos to understand it better. So see you in the next video.